Hello once again, it's Tubalcain, your YouTube shop teacher, and I just shot an introductory shot here, and I'm redoing it because I was too venomous in my attack against airport security, so I won't go there other than to say that why are they all mean? Can't they hire some nice people? Okay, what I'm going to cover today is center gauges, sometimes called fishtails, and actually the attachments made for them. And I'll show you in a separate clip here in a minute the purpose of these if you have never seen one. If you would like one, you can no longer buy them. I did extensive research, meaning I looked at 3 catalogs, and I can't find them anymore, so I don't think they make them anymore. I'll show you how to make one, but even if you think this is worthless, and it probably is, why, bear with me, because I am always, I hope, presenting new operations on the milling machine and lathes and so on, and that's what really this is all about. Not really about making this, it's about learning how to use these tools. So let me talk a little bit about center gauges first. I get a lot of comments from people that I didn't cover this or I didn't cover that, and I probably did in many videos, and I am hesitant to repeat things, but then again I always have brand new viewers. But also much of this was covered in my individual courses on the Logan lathe, the South Bend, and so on. So some of those things are in greater detail than what I do here on free YouTube. But the purpose of the fishtail, of course, is to aid you in grinding your 60-degree or 55-degree threading tool that I just held up to this. So that's what some of these notches are, but they serve a dual purpose, and this is 60 degrees on the end here. All of the companies made these. Some of mine are Starrett, Brown and Sharp. I even have a Mitutoyo here someplace. Maybe somebody can explain to me why this Mitutoyo was made in USA. That's kind of surprising to me. And here we have an owner's name, of course, who is busy taking his dirt nap. So several different brands here, including a rather rusty old, what is this? I think it's a General. Yeah, it's a General. I prefer the satin chrome, of course. This is a Starrett Whitworth. So I say they're 60 degrees. This isn't. This is 55 degrees. But then again, I have never cut a Whitworth thread. That's for you boys over in England, and there's a lot of wonderful model makers over there, and I think they're still using that. But let me talk now about the attachment here, and I'll cut real quickly now to the other video where I'm showing you how this is used, although you probably know. If you do know, skip right on through it. See you in a minute. Now I think all of you understand that these angles here are 60 degrees, except for the 55-degree one back on the bench, of course, and the purpose of that is to help you grind your tool bit, although this is a preformed one. But I always found it inconvenient to hold the center gauge like this as we square it up. So the purpose of the attachment, there's a little V-groove here, and it can be so easily held onto the work, the round work, as you manipulate and center your threading tool. So that's the purpose, and that's what I'm going to make here in this video. And here's my disclaimer. Virtually no one is still using this type of single point tool, or probably the kind that you grind. You're using the carbide ones, as I do myself actually, but rather than square it up with a fishtail in this manner, archaic manner, I just square up the whole tool post by moving it like this and then bring it up against a chuck or a faceplate, and you've watched me do this countless times, and this is really the way to square them up without using a center gauge. But nevertheless, I will forge on with my manufacturing of buggy whips. This is the 1941 Brown & Sharp catalog, printed just prior to Pearl Harbor, and there it is. You can read that if you would care to. It's 50 cents. Well, that sounds pretty cheap, but that was probably a half a day's, or I should say probably an hour's worth of work, 50 cents an hour. A lot of people were still getting 50 cents an hour, so that was expensive. These are hardened and tempered. Mine will be made of soft steel. Here it is in the Starrett catalog from 1990. Well, even that's a few years ago, isn't it? Almost 30 years, and they don't show the prices because they changed the prices daily back then. But just to give you an idea that the big companies did make these, and you probably won't find them except on eBay now. And often they got lost. Now, I told my brother I was going to make this video, and he said, "You're wasting your time. This was a product that never was really needed," but I like them. There's the Brown & Sharp, beautifully color hardened. Notice how the blade is held in there by a little flat spring, and it's really virtually identical to the Starrett. I don't think there's anything for them to even patent on these. And there's the Starrett, and I've had this one forever. You can see it's about the same on the end. But I'm going to avoid using that spring simply because I think it would be difficult to make. And that's a 90-degree groove. And you too can make one of these. You only need about $10,000 worth of equipment and special cutting tools to do it. Presto, and this is the one that I'm going to make. Again, 90 degrees, and we got a little slit about 50 thousandths, and I'm going to hold it in place with two 440 set screws, probably the hardest part of the job. And this slit, again, you know, a good way to measure a slit like this is either with feeler gauges or the wonderful Starrett taper gauge. And you can see from this that it's not quite 50 thousandths. I thank you, Randy Richards, for sending me yet another scriber. You know, he makes these, I think he sells them too, so check out his videos if you would. But I believe the brass one is the very first one he sent me some time ago, and then a stainless steel one. But I said, you know, Randy, they just roll all over my bench and then they fall on the floor, and that dulls them. So I said, we really need a hexagon one, and I don't know if I was the inspiration or not, but I just like the hex. And so he made this one for me, and that's, I don't know how long ago that was, but he does a great job of engraving. He even put serial numbers on them and my name and so on. But I got this one in the mail the other day, yesterday to be exact, and they can be put in your pocket, you know, but don't try that airline security. That's why I was talking about airline security to start with, you know, and I had to cut that out because I became, well, you know how I like to rant. And some people don't like that. They'll stand up for whatever I am against. But we all have a right to our opinion. There it is, Randy Richards in the shop as a serial number, which is the #1 serial number. Dedicated to my channel. Real quickly here to show you how the spring holds the gauge in place. You have to make sure you push it in all the way so it's square. Now this is 7/16 diameter. It may not look like it, but by the time it's been machined, you know, it loses some of its round shape, of course. I'm starting with 7/16, just mild steel. I faced one end. You want it to be square for the way I'm going to do this. Now watch the different operations that I do, and the order of the operations really is pretty important, even though I may not mention that as I go along. And this is only, I believe, what did I say, 1¼ inch long, but I like to start with a longer piece, so I got 1 3/8 long. There'll be no drawing. 1 3/8 long. If you have any interest, jot down some of these dimensions as we go along. All right, let's go over to the Bridgeport. Work safely. Wear your safety glasses in the shop at all times. Now, what I've done already is to put the 7/16 stock on parallel so that it's sticking just up a little bit here. Doesn't matter too much. Notice I allowed a little bit to stick out, so I got some place to put my edge finder. So I'll find the edge of this and then therefore the middle. So that's the 200 thousandths end. I like that one. I'll speed up through this. And so half of that's 100, and the diameter of the stock is 7/16. The radius of that is 7/32, or 0.219. So added together, it's a total of 319 from the edge that I have to move once I find the edge with this Starrett edge finder. Now I'm on the center of the work, and I'm looking at my digital readout even though you can't see it. Now I'll tell you why I wanted to be on the exact center. This is a 3/8 end mill, and since it's 7/16 stock, now I can machine in here with impunity. That is, I will not hit the hardened jaws and ruin the cutter and possibly damage the jaws. Furthermore, that already puts me on center for when I use this KBC 90-degree cutter. So I'll be doing two things in this operation, one flattening it, and the other is to put the V-groove in. I want this dimension to be 350 thousandths or thereabouts. That dimension right across here. So therefore I will come down, touch off with the end mill, and feed down 88 thousandths, and I will mill up to the second line. The first line there, magic marker line, is 1 3/8, and the other one is 1 1/2. So I want to go a little bit more than 1 3/8, always with some waste stock. So let's do that. Now I know I go into great detail on some of these operations and how to do them. If this is too much for you, move right on, but some people like every detail and every little bit of instruction, so that's why I do that. As always, I want you to remember that you can never be too rich or have too many tools. Now, I like to just touch off like this. You can do it with the machine running or not. I have a feel for it. When it comes down, you can put a piece of tape in there, but it's just not that critical. So I'll come down, touch it, and I'm locking the quill. You can't see that. I'm backing off a little bit. And with the machine set at 1100 RPM, I probably could run it faster than that. This is mild steel, but I'm going to, remember, take off 88,000, so I think I'll start by taking off 75, and then I'll have a finishing cut. So I'm zeroing out the knee, you can't see that, and I'm raising it 75 thousandths. Reading the dial on the knee crank. And now the final few thousandths that take me to a full depth of 88 thousandths. This is a finishing pass. I always feed a little slower on the finishing pass. So I'll speed it up. I have installed this KBC drill mill. Remember, that's 90 degrees and it's carbide. And I'm still on center. I have not changed that. And I'll come down and touch again. Now, if you want to put a piece of paper in there, you can, but again, it is not that important. And with this sharp cutter, it tends to tear, see? So I'll just bring it down until it barely touches. I am locking the quill. I back it off. Now, that V-groove is going to be 125 thousandths deep, so I'll take two passes. The first one will be 100 thousandths, and then I'll take a finishing pass of 25 thousandths. It's a very sharp cutter. It's carbide. I could increase the speed, but I'm too lazy. I've raised the table the final 25 thousandths, and I will speed the video up. Now at this point the project can be removed from the vise, but do not remove it until you do both of those operations. And if you had a notion you could make two of them at the same time, it wouldn't be any more work. I'm at the Boyce crane bandsaw, and I will cut it off a little bit longer than 1 3/8 so I have some material left to face. You can use a hand hacksaw. Alright, it's rough sawn, and I'm going to face it down to the line there, which will be 1 3/8. Now it needs to be held in a 7/16 collet. You can't really hold that in a 3-jaw at this time, but see, it works perfectly in a collet, this being a R8 just for demonstration, but I'll be in a 3C here on the Atlas lathe. Alright, it's rough sawn, and I'm going to face it down to the line there, which will be 1 3/8. Now it needs to be held in a 7/16 collet. You can't really hold that in a 3-jaw at this time, but see, it works perfectly in a collet, this being a R8 just for demonstration, but I'll be in a 3C here on the Atlas lathe. And I will face it down to the line here on the Atlas lathe, but of course if you don't have collets, this could be machined on the milling machine as well and squared off. It just needs to be squared off nice, and you'll see why in a minute. The next thing I'm going to do is to put the slot into this to hold the actual gauge. Now I measured a bunch of these as far as the thickness is concerned, and it's just all over the place. There's no consistency at all. For instance, that one's 38 thousandths, this one is 33 thousandths, this Brown and Sharp here is 48 thousandths. So I looked through my cutters, and I have a Brown and Sharp cutter here, but they just have a number on there. It's a number 15, but it happens to be a little bit over 50 thousandths, so that's perfect since I'm going to use set screws to hold the gauge in there anyway. So this one just happens to be mounted on an R8 arbor, so that's the one I'm going to use. And it's fairly sharp. I used it once already, so it's going to do the job. Now, this is kind of a tricky setup because this slot has to be exact depth. Well, the depth doesn't really matter as long as I don't go all the way through, but consistent measurement from one end to the other as far as that depth is concerned, or the center gauge is going to sit in there at a slight angle, not like that, but I mean, even if it's just a few thousandths off, it would not really work properly. So I will try to get an accurate dimension, and I will be holding this in a relatively precarious position, as you will see here momentarily. Now, as I make this setup, I need some kind of block that is perfectly square on the end, and I checked all my parallels. They aren't very square. I suspect yours are the same. So in the end, I found this 2-inch Joe block. Actually, it's a dual block, and it is perfectly square, so that's what I'm going to use, and you'll see how here presently. So let's go on over to the Bridgeport again. The cutter is mounted, and I reduced the speed to 600 RPM. That's about 3 inches in diameter, and even that may be too fast, but I'm not going to put it into back gears. Now, as I said many other times, there's just a lot of different ways to make a setup, but this is the way I came up with, and sometimes people say, well, why didn't you do it this way? Well, because I didn't think of it. You know, there probably are better ways. But what I'm essentially doing here is holding the workpiece like this on those two parallels, and I'm squaring it up with this Joe block that I just talked about, and the Joe block must be against the fixed jaw. So I'm pushing that way, and then also up against this surface, because the surface that I milled here we know is parallel with the V-slot. So I will be pushing this up against like that, not at an angle, but it's got to be right on there, and I'm only gripping just a little bit on the end because this slot is going to be 150 thousandths deep. That's pretty deep, so I have very little to hang on to. That's why I said it was precarious. So you know what I'm doing here now, as I have my index finger against the work, pushing it against the Joe block, and I'm also pushing toward the fixed jaw, but yet I think I got it just where I want it, and I'm tightening it down, and then the Joe block can be removed. So that's the setup. The next thing I need to do is to set the slitting saw, the cutter, on the center line of the work. Now the distance down, once I touch off, is half the thickness of the cutter. This is a 50 thousandths cutter. And the radius of the works, so in other words, I'm adding together 25 thousandths and 0.219 for a total depth of 244. So I'll bring this down. I do like to use paper for this type of touch off until it just drags just a little bit, and then I will lock the quill. Now I'll back the cutter out of the way so you don't break it, and I'll raise the table 100, 200, and 44 thousandths, and now I'm on the center of the work now and ready to cut. I'm going to take some light cuts because of the precarious setup. And the depth that I'm going to cut, if I might have said that already, will be 150 thousandths. I'll be touching off and then setting the digital readout to 0. And I'll go by the DRO as far as the depth of the slot is concerned. Now I'll touch off, and this isn't too critical. I could hear it touch. Now I'm going to set the digital readout. The first cut is 50 thousandths rather. Now wear your glasses, as you always do, because imagine what would happen if that slitting saw shattered. And this is the third and final pass for a total of 150,000. I'm being careful not to strike the vise. I think I told you that we did the easy part. Now this is going to be the hard part. 2 tiny 440 holes, and they're counterbore. So I'm going to do the counterbore first, simply because if you tried to drill on the round, you know that the drill bit would deflect and certainly break with a small diameter. So that's a 5/32 end mill in there, pretty small in itself. And I've already located a couple holes on there, and I don't want to get too much into dimensions here, but the 2 holes are in fact 950 thousandths apart, center to center. And the first hole here from the edge is 225 thousandths. So I'm going to make those counterbores now, and I've already touched off on the end, so I know where that location is. And looking up at my digital readout, I'm moving it in the correct amount, and I'll be on the center of the first hole. Now I still have to decide how deep to go, and I'm not even sure yet until I get a little closer there. I can barely see it myself. Matter of fact, there's a better view on the monitor than there is with my bare eyes, even with my optivisor. So I often refer to the monitor to see an enlarged view of what I'm doing. So the same as the dentist does. And he wears an optivisor too, at least the one I got. So then as far as this direction, that is away from me, the operator, I have some little layout lines on that, and that's something, if anyone does ever make something like this, that they just can determine by themselves. Because remember, I made a prototype, and no drawing at this point, and there will be no drawing. I'm ready to mill. I am 303 thousandths from the end, and then I zeroed out the DRO, and I'm going to go in this direction away from me up until that line, and I've got my little flashlight so I can see that. And when I reach the line, then I will also set the y-axis on the DRO for 0 so I can repeat myself on the second hole. That's all there is to it, and I can't see much on the screen. I know you can't either. I have moved 950 thousandths down to the next hole. I'm watching the digital readout. Okay, the counter bores are done and I'm ready to drill and tap. Now I've got a small chuck installed in a little center drill, and I'm still in the same location in the x-axis as I was for the last counter bore. And as far as in the y-axis, all I can tell you, there was no dimension there. I'm pretty well centered within the counter bore. So I'm going to go ahead and drill just enough to get it started, and then change bits here, and this will be a number 43 bit, and I'll drill through one side, that is, through the slot, into the slot. Actually, I'm going to go a little farther than that. I want to go a little bit into the other side, and the reason for that is that when I tap this, there's a little bit of room for the tip of the tap to go on into the other side, so that I don't have to use a bottoming tap. I'm not sure I have a bottoming tap, but I don't want to use one anyway because they're so likely to break. Did you notice that little black mark on the drill? That was left from the prototype. That's how deep I went. I won't show the other one because it's just a matter of moving the table down and repeating the operation. And I'm going to do the tapping at the bench. Back at the bench, and with this 440 tap, I use the very smallest tap wrench I own. It sure looks like a cheap little thing, but you do not want any more leverage than absolutely necessary, because as it is, there's a 50-50 chance that I will break a tap off and have to send this to Pensacola to have Adam Booth remove it. Does he do the little stuff? Always trying to tap straight, looking in two directions. I won't show all of this, so I'll save myself the embarrassment when it breaks. Success! I did not break it. I have to use my very smallest, or one of my smallest needle files, get the burr out of there. There we go. Now notice that 90-degree cutter leaves a little flat in the bottom, which is just fine because that's true with the Brown & Sharp one as well. Alright, now for some set screws. I really didn't have many 440 set screws around. I had to break into this selection. You know, they're really tiny little things. Alright, got those. They used to make a lot of fasteners in Rockford and many other metalworking items in the city of Rockford, Illinois. Estwing, I know, is still there. For those of you who are gluttons for punishment, you can stick with the spring system, as did Starrett and Brown and Sharp. And really, that wouldn't be bad, other than how are you going to fasten on the ends, and you would have to mill some little slots there and so on. But here is a selection from Brownell that I've had since the dawn of time. Springs flat and round. So there's a piece that would be possible to use. But if you're going to use something like this, you would have to make the slot a little bit wider to accommodate both the spring and the center gauge. So it's up to you. But as aggravating as little screws are, I think that might be a little worse. In fact, if anyone ever builds one of these, and every time I say no one in the world is going to build one of these, someone does, and then they tell me. So if anyone does make one of these, put it in the comments. Also, from this view, remember when I told you that I was holding it in a milling machine vise pretty precariously, because that slot there isn't too far from the bottom of the V-groove, so I was literally holding it by this, well, I should say by about that much, what is visible. That's why it was precarious. Alright, let me put this in, snug it up, and when I snug it up, I will have to make sure that I hold that tightly, as I am doing now, so that the set screw doesn't displace it a little bit. You know how screws react with the work, so let me do that. This is the Mitutoyo. That's it. That's what she looks like. I should put a little bluing on it. Gun bluing. And remember, I talked a little bit earlier about the depth of the slot. That if it isn't just so, you're going to end up with it going in there cockeyed. But the way it is here, I got 908 thousandths on that end, and on this end also 908. So let me move out a little bit there. Yeah, 908 on both ends, so it's spot on. I was a little surprised myself. So there she is. A lot like the original ones. Yeah, there's the Starrett, Brown and Sharp, and the tubalcain. Make yourself one if you don't think it too foolish. Hope you enjoyed the video and the different operations that I performed, not necessarily the project. Remember, the project is only a vehicle, just a vehicle to learn machine shop. Sometimes the projects are useful, sometimes they're useless. I hope that you find this one at least in between. This is tubalcain, your YouTube shop teacher, saying so long for now, and I hope to see you in my next video, and there will be a lot of them yet this winter.